A question about free body force diagrams, which are pretty tricky really, so we'll go through it slowly. So figure 1 shows a boat floating on the sea. The boat is stationary. So stationary is one of our motion words, and we're always looking to explain motion or movement in terms of the forces acting. So part A of the question shows us a free body diagram for the boat. Complete the free body diagram. Now all a free body force diagram is physicists being lazy and don't want to draw a boat, so instead we draw a dot. Okay, so that dot represents the boat, and we draw all the forces as arrows. The length of the arrow tells us the size of the force, the direction of the arrow shows us the direction of the force, and all the arrows are drawn with the base touching the dot and the tip of the arrow pointing away from the dot. Okay, so complete the free body diagram for the boat. So it shows us the weight being the vertical force of gravity pulling the boat down towards the centre of the earth. Now, because we know that the boat is stationary, that means that the forces are balanced, or to put it more scientifically, the resultant force is 0. Okay, so we know that there needs to be another force to balance this weight force. Okay, so we look at the situation. The boat is floating on the sea, so it is being supported by the sea, which is water, a liquid, and we should know that the supporting force from a liquid or a gas is upthrust. So for the second mark, we need to label our arrow upthrust. So we know there's another force and it's upthrust. First thing we have to do is draw the arrow on to represent upthrust. So base of the arrow starting here and tip pointing in the direction of the upthrust force, says it in the name, up. So we want an arrow that's going vertically upwards. Okay, and because it's stationary and the forces are balanced, that arrow needs to be the same length as weight. So it's equal and opposite to weight, which is how we know they're balanced. And because they've labelled this arrow as weight, we need to label our arrow with the name of the force, which is upthrust. So you get 1 mark for labelling it upthrust. You get 1 mark for a second arrow that's pointing up and is the same length as the weight arrow. So I would recommend measuring that with a ruler. And this is what it looks like. And you would add the label upthrust. So that's our free body diagram complete. Calculate the mass of the boat. Use the information given in figure 2. Gravitational field strength is 9.8 newtons per kilogram. Give your answer to 2 significant figures. So let's look back at figure 2. The information that we haven't used is down here where it says scale. 1 centimetres is 5 kilonewtons. So what we want to do is measure the length of this arrow, okay, in centimetres. And you should find that it's 5 centimetres long. So the weight arrow is 5 centimetres long. 1 centimetre is 5 kilonewtons. So that means each centimetre is 5 kilonewtons, so 1 centimetre is 5 kilonewtons, 2 centimetre is 10 kilonewtons, then 15, 20, and finally 5 centimetres is 25 kilonewtons. Okay, kilo means times by 1,000 kilos, sorry. Newtons is the standard unit, so we want it in newtons, so we have to convert. Kilo means times by 1,000, so 25,000 newtons is the weight. Because it says gravitational field strength, we know gravity is linked to weight, so that should make it, that's how we know we're interested in the weight arrow rather than the upthrust one. So then we need to look at our equation sheet. If it wasn't 2022, you would have to remember this equation. The equation we write down is weight is mass times gravitational field strength. And then we need to substitute our numbers in. So weight, we have 25,000 newtons. Mass is what it's asked us to calculate, so we just write in a small m for mass, or the word mass, times gravitational field strength, which it tells us is 9.8. So we get this, 25,000 equals mass times 9.8, and we need to rearrange that to get mass. So mass is currently times by 9.8, so we need to do the opposite of timesing by 9.8, which is dividing by 9.8. And we use the rule, which is 25,000 is on its own on one side of the equal, so that goes on top of the division. So we get mass is 25,000 divided by 9.8, which is 2,551. And I would strongly recommend that you then go and type in 2,551 times 9.8 and check that you get 25,000. Because it's easy to make mistakes with things like this under pressure of exams. And then the final thing that we have to not forget is it says give your answer to 2 significant figures. So to get the 4th mark, that's got 1, 2, 3, 4 significant figures. So we need to round it to 2. So 51 is bigger than 50, so we're rounding up and we get 2,600 kilograms is our final answer. Okay. And then the final question, when the boat propeller pushes water backwards, the boat moves forwards. The force on the water causes an equal and opposite force to act on the boat. Which law is this an example of? The only laws to do with the forces topic are Newton's laws, and you just are expected to remember that Newton's 3rd law tells us that every action has an equal and opposite reaction. So you have to write Newton's 3rd law.